can see your screen. Awesome. All right. Well, thank you everyone for joining. I really appreciate it. Today, we're going to be going through a walkthrough essentially of being able to deploy a very simple web application to Azure using a service called Azure Static Web Apps. And what Azure Static Web Apps gives us is pretty much an out-of-the-box experience of sort of hooking up things together. A lot of things hooked up for us in the back end, including being able to like push code changes to GitHub and then use GitHub Actions to actually be able to push the code out directly as well as you're making changes and building on your web application. So really quick, just going through the architecture of what we have for today that we're going to be working with. So this actually, let me put this GitHub repo in the chat if you want to go ahead and take a look at it or follow along or clone it, whatever, feel free to do it yourself. So there are basically three components here. There is a very simple React app, which actually, fun fact, was created by the Frontend track. A group of us worked on it during the Hacktoberfest in October of last year, actually, to build what you see today, essentially. But it was built with mock data, so it wasn't having any sort of API or anything in the background. So I figured for this session to sort of show how we can take that and deploy it into Azure, I introduced an API as well, which is just one endpoint really at this point. It's quite simple, and we'll go through that a little later. I'll show you the different parts. So the API is an Azure Function, which is the serverless component here, actually, yeah, the serverless component here. And then it talks to a database, and I chose Cosmos DB is Azure's NoSQL managed service that they offer. So the Azure function talks to a Cosmos DB database to get the data to surface it to the React app, essentially. So the first thing I want to show is, excuse me, this application can be run locally. All the pieces can be done. So I'm going to show really quick first what it looks like when you run it locally on your machine. So for the first thing with the Azure Cosmos DB, there is an emulator that's available that you can install on your machine in order to have like a local database that you can play with and work with for your application. So in my case, I'm on a Mac, so there is a Docker image that's available. So you do need to have Docker installed to be able to use it. So I already have it pulled and running down here. There are a few instructions on how to set it up. There's some certificate and things involved, but the documentation here actually walks you through it pretty well. So I'm not going to go through that in detail, but definitely, you know, if you try it or something, feel free to ask questions at any point in time over here. Feel free to interrupt anytime. So right now I have the Azure Cosmos emulator running, and when it's running on the machine, you're able to interact with it with basically a web page that's located at localhost 881. That's where it's running. And this is the built-in key and connection string that it gives you out of the box when using that emulator, right? So what I'm going to do here is I'm going to go ahead and make a database. We'll call it called workshop, and I'll just set it to this manual, and we can go ahead and make that. So this is going to be the database that will be used by the web application, which I'm going to show in a minute. And the idea of Cosmos is your data lives inside of a container. So in our case, I'm going to call it resources. And the partition key is how it actually, it needs to be as unique of an ID as it can be, is what I understand. And that's how it's able to partition data and actually store data. It even like handles being able to, like if you have a lot, in my case, it's obviously quite small, but if you have a lot of data, it's what it uses to actually partition and scale out, share out the data. So this is what I'm gonna do here. And this does let you get data from a JSON file. So I have one here that I'm gonna go ahead and upload. So it created 12 things, and I close this and go back in. Now we can see the actual data here. So this was basically uploaded from a sample resources JSON that I made. And this data ultimately will get surfaced as JSON by the API to the React app, which I'll show in a minute. So this is the code here. And the API is a .NET Azure Function. And what we have in here is a get resources endpoint. Actually, let me go ahead now that I have the database set up. I should be able to now run the actual application. I'll talk about the configuration in a minute. So with Azure Static Web Apps, because it's two pieces where you have a React app and APIs running as Azure Functions, they provide a CLI, Azure Static Web App CLI, that when you run this command, it will actually run both the web, as in the React app in my case, and the Azure function together and have them connected to each other as well automatically. It sort of takes care of that for you behind the scenes to run both and have them being able to talk to each other. So I'm gonna do that here. And to explain what this is doing, so the SWA there, so it starts up the React app automatically, but technically this is not the URL that I need to go to. It is actually this localhost 4280, where the localhost 4280 acts as a static file server to serve the React app, and it also acts as a reverse proxy for any calls to the API, and it's able to funnel those into the Azure function as well. So just to show you what the app looks like. So this portion here that you're looking at is the React app, which is under the UI folder here. And basically now this particular portion here is all static text. The part that talks to the API is in this resources portion. And it just loaded this data that's in these tiles here from the Cosmos DB database using the Azure Function API is what it did. So to go back here, so the React app, there is a resources component, which is this here. And what it does is it fetches from this API resources. And this API resources that it talks to is the Azure function inside of this API folder here. This get resources, because it's called resources like that, and because when I configured it, I'm saying it's under /API, or is under the /API folder. The static web apps knows to route /API/resources to this function to get the data, essentially. And what this function is doing is it's talking to the Cosmos DB that I have running locally, the emulator, and it's just getting everything from here, all these 12, and surfacing it to the React app, and that's what you're ending up seeing over here. Just to show you real quick, I should have opened this before, but just to show through the network tab, you can see it's going to 4280/API/resources, and it's returning the JSON, which is what is surfaced here in the UI. So this is how you can basically get this running locally. One important thing about if you're getting this for the very first time, for Azure Functions, when you're running locally, it generally looks for a local.settings.json file for any external configuration that you need. And in this case, because it's talking to a Cosmos DB database, locally in this case, it needs the connection information in order to know, okay, which database am I talking to? Because I could have multiple things in that, right? So this is how you can give the connection information to connect to the database, but this is only needed for local development. In Azure, when we actually deploy it to Azure, it uses something different in there to actually get this configuration information. So I'm gonna go ahead and stop this. Oh, and just to explain, I guess, really quick too, what this command here is doing. So the SWA is the CLI, as I said, for Static Web Apps. And when you say start, the app location here as a parameter is pointing to the UI folder. It's basically saying, here's the the UI app, and you can use React. I mean, I use React here, but you can also use others like Angular and Vue.js and things like that. So it's able to support different front-end frameworks of front-end apps, different types of front-end apps, I'm sorry. So what happens here is sorry, the Zoom thing is coming in the middle. So the application says where is the folder location of the UI app. The HTTP localhost 3000 is basically saying this is the general place where the React app serves like a dev server so that you can actually serve the React app. And then the run npm start is generally the way, if you were running the React app alone, then you would do npm start. So this is the command you're giving in order to start, again, locally, the React app itself. And then the API location is basically saying where the API is located, and it's giving that ./API folder. So this is how the Static Web App CLI knows how to connect the front end with the API running. Sorry, is someone wanting to ask a question? Okay. Let's see. So that is for the local developments. So now we can get into the actual deployment to Azure for this web application. So you can definitely use the Azure portal to make everything through the UI. But for today, I'm actually going to use something called ARM or ARM templates, Azure Resource Manager templates. And this is an infrastructure as code way for you to be able to deploy resources in Azure. So in our case, we need to create two things. We need to create a static web app, and we need to also create the Cosmos DB. So in order to do that, one of the ways is to use what's called an ARM template. And that is basically a JSON file. So in this deployment folder is where I have it located. So this first JSON file here is for the Cosmos DB to create it in Azure. And the static web app one is to create the static web app. And the static web app also needs the configuration, as in the connection information for being able to connect to the Cosmos DB that we make in Azure. So I've written a script that actually goes through that process. So what I'm gonna do now is I'm gonna run that script because it takes about maybe 2 to 3 minutes to run. And while it's running, I'll just go through what exactly is happening step by step. So in order to run it, we go into that deployment folder. It's basically a bash script. So we're gonna do that. And while that is running, basically we'll go through what this is doing. So the first thing in Azure, everything that you make in Azure lives inside what's called a resource group. And a resource group, it's basically like a container for all your services. And you can basically see the cost of your services and everything through that resource group. So it's like an organization, essentially. So that's the first thing that we're doing here, where we're saying create a resource group with this resource group name. And you also have to specify a location of which region you're making the resource group for. So in my case, I called it this Cloud Workshop Resources, and I gave the location as East US. That's where I'm located. So that's the first step. After that resource group is created, we're basically going to deploy this Cosmos DB ARM template here using this command, right? And what this is this is all using what's called Azure CLI. And one thing to keep in mind is I've already done this before. That's why it didn't make me do it, and it's actually running right now. But you do have to do an AZ login. You have to run AZ login first, which will make you log into your Azure account. So from there, it knows which Azure account it's basically running all this in, right? I forgot to show that before, I'm sorry. But I already started it. But because I've done it before, it knows that it's already talking to my specific Azure account. So over here, this is basically saying for this resource group that I just made, go ahead and deploy this JSON. And these are certain parameters I want to give for, as I showed you when I was running the emulator, which was local, I want to give a name to the Cosmos DB itself when it makes it in Azure. And then I want to also provide the database name and the container that will be created within, which was the Cloud Workshop and resources that I did when I did locally. So that's that portion to create the Cosmos DB. Once we create the Cosmos DB, for the static web app, or specifically the function within the static web app, it needs the access or the connection information rather to the Cosmos DB. So that's what these two lines are doing, where it's basically getting, so if you see in this local settings JSON here, it needs a Cosmos DB account information is in the endpoint that it's talking to, and then the key that will be generated, which is something that Azure will generate when it creates the Cosmos DB for us. So, sorry, going back here. So the first step is this first command is saying get that account, which is that HTTP endpoint. And this is saying get that key that gets generated. So after we get those two, this is basically stored here so that we can provide it as app settings into the static web app. So this portion here is the command to run to deploy static web app using this JSON file, again, in the same resource group, and providing these parameters where there are only certain locations that I'm allowed to make the static web app. So that's why I had to choose East US 2. I couldn't do the previous one. This is just a name that I gave up here. I just call it Static Web App Cloud Workshop. You can obviously call it whatever you want, totally up to you. And this portion here is, if you notice, it is basically similar to what you see in this local settings JSON. So this is the configuration information, right, that the function needs. So that is why this portion is here. So when running this whole script, oh, it looks like it finished. Yay. So when running this whole script, it will create the resource group, it'll create the Cosmos DB, get the connection information Cosmos DB, and then create the static web app with that configuration information, right? So now let's go into the portal, and if I refresh, I should see my test cloud workshop. The Cloud Workshop resources resource group, and in there I should see two things: the Cosmos DB and the static web app, right? So that script ran through all that and did this. So in the Cosmos DB, when you go to Data Explorer here, this is a UI, and if you look at it, it's very similar to the emulator one. It created the Cloud Workshop in it, and it created the resources in it, but it is empty. So this gives me the same upload functionality we saw with the local emulator. So I will go ahead and choose that JSON, say upload, and that lets me create that. So if I close this window and look at it again to make sure, yep. So here's all my 12 resources data. So that's in the Cosmos DB now. And going back to the static web app, so the static web app is meant for both the React app as well as the function, right? So keep in mind, I haven't deployed the code yet. So the React app files, like the JS and all that it makes, that's not there yet. And actually neither is the function. Yeah, so I haven't deployed the actual code yet. So now that is our next step. Oh, yes, this is why I have a handy dandy read to show me all my steps. So one thing now that is needed is, in order to deploy the code from my GitHub repo to the static web app now, we need to give a specific token that's available here. So in the static web app, in this managed deployment token, this token is something that will need to be put as a secret in my GitHub repo. Over here under actions. So the way this works is, under this GitHub workflows folder, .github workflows folder, there's a deploy YAML. And typically when you create, this is something I didn't do because I didn't want to set up the automatic integration between GitHub and the Azure. I just didn't do it, but it does actually let you do that, such that when you create the static web app, and actually let me show you really quickly, if I just say, oh, not here, sorry. Inside the resource group, when you say create and when you go through the UI, you will see, and I do static web app here, it does make me, okay, I'm just gonna put something there. I'm not going to create it. I'm just going to show you what it looks like what it asks for, basically. So it does have those deployment details and source, and you can basically sign in with your GitHub account. And when you do that, you have to authorize and give it permission. And once you do that, what it does is it will actually generate this YAML file here. Sorry, wrong place. This YAML file here. And what it does is it will create also this Azure Static Web Apps API token as a secret in your GitHub repo, right? This is something that does automatically for you, but I didn't do this when I did the JSON. I just said create the static web app, but don't have any automatic integration. So I can set that up myself. And that's basically what I've done here in a separate script. Using GitHub CLI, I can actually say, run the script here, go into that resource group, go to that static web app, get that managed deployment token that we saw before. Sorry, let me go back there, here. This deployment token that it generated for when creating this. It basically gets that and it will create it using GitHub. So GH here is GitHub CLI, which you do have to install. I have it installed already to do this. And it will actually set, create a secret, create it or update it if it's already there, called this Azure Static Web Apps API token, and set it to that value. Okay, so I'm gonna go ahead and run this one as well because I need. So without doing this, when I trigger the GitHub action, it won't work. It will error out because it doesn't have access to the static web app to deploy the code there. That makes sense. So let's go ahead and run that. So it's set the secret. And that secret, actually, you could see under the GitHub repo when you go to settings. It's in secrets and actions here. And this is the one, and it said update 13 seconds ago because I just did it. So by virtue of having this YAML here under this folder path of .github/workflows, this is a GitHub action YAML that now when I go to this actions over here, it's what shows up over here. And it's something that runs on every push, like every time I push to the main branch on this repo, or if I also create a pull request and approve and merge the pull request, that will also trigger the GitHub action to run and deploy the code. So that's what this portion here means, that either on push to main or making a pull request to main, it will basically trigger this action is what it's saying. Actually, even creating it will do it as well. So that way, if you want to, the idea is if you want to deploy to, and you have that option to deploy to some staging environment, Static Web Apps gives you like a staging and a production that you can make so that you can deploy to a staging environment for pull requests if you want to, test it out and see if the changes work or something like that, or view them or something. It gives you that functionality as well. So, but basically the way this works is there's a build and deploy job that says if the event name is push, meaning a push to main, right? Then go ahead and check out this repository and then build and deploy. There is a static web apps task just available in GitHub Actions. Again, something that they've already built to sort of have the experience just there for you so that you don't have to do this yourself. And what that takes is it has to take, similar to the the static web apps CLI that we saw before, where you had to give the folder paths to the UI and the API and all that. That's kind of what these two are. So the application is saying, where is your React app or your front end app rather? In my case, it's in /UI. And then where is the API located, which is API here. And the output location is where are the files for the front end app when you build it. So when you build a React app, it makes a build folder inside, like in the root of the React app, basically. So that's what this build is for, because what the GitHub action will do is it will build the front end app, and then that build folder will get made. So that way it knows that, okay, this is the folder that has the output of things that were built with the front end app. Okay, so that's what this is. This portion is specific to closing a pull request, basically. So that I haven't actually tested this, but I believe the idea is when this finishes, like when you merge the pull request, then that's how it knows to actually trigger the action. So this is the GitHub action portion. So now I did the linking. So now we are ready to actually deploy it. So what I'm going to do is, these failed before because I had deleted the entire thing and I was pushing some stuff and I was updating the README. So it doesn't matter what I push. Every time I push anything to main, it's going to trigger this action. It's the way it's configured right now. So that's why you're seeing some failures here. So what I'm going to do, I'm going to go ahead and trigger this, run this. And this will basically go through and build, and it should now go ahead and deploy the code, the React app as well as the function app to those resources that we just made in Azure. So I'm going to close that. And that takes a few minutes. So right now it's checking out the repository. So what happens with GitHub Actions is with GitHub, they have like hosted runner, which is basically their own, I guess, virtual machine, if you will, or something that they run themselves. And within that, it's running through all these steps. So that's why it has to check out the GitHub repo, go through the build and deploy. Right now, it's still basically checking it out. Actually, no, I was doing something else. Okay, so it checked out the repo, now it's building. So it has to build a React app, and then it also has to build the .NET app for the function. And then together it'll be able to deploy it because it's going through that static web apps task specifically. And eventually, once it finishes, we'll be able to browse. So it generates this, when you create a static web app, it always generates a funky URL. In this case, it's Summer Forest. So we'll be able to browse to this and basically see what I showed you when it was running locally. We would see the same thing. One thing I realized, okay, so the configuration settings here, I wasn't seeing it before. And, oh, I think I didn't go into it. So these configuration settings actually came from the previous script when I deployed it. So now the function, once it deploys the code, the function will use these to connect to the Cosmos DB in here in order to make it work. Let's see, it is deploying. Okay, so it finished the React app here, and now it should be going through the .NET one. Looks like it has to install .NET 6. It's kind of neat to see it going this way. And it should be pretty quick to actually build because there's not a whole lot in the function. Once it finishes that, yeah. So now it's building the .NET app here. And also to mention with Azure Functions, it does support other languages too. So you could use JavaScript. I think it also supports Python, Ruby. So you have your options as to what to use for front end as well as the back end, basically. And what's nice about the static web app is it's sort of, I guess you could call it an opinionated way, like it basically gives you the full thing just out of the box. Here's the way you generally want to set up a web app with the front end and APIs. And it also automatically gives you this continuous integration flow of being able to push your changes and, have it be live right away without you having to configure all the pieces yourself. So that worked there, which is great. And now if I go in here, I'll go to that. So there's our React app there. And what I want to do is I want to keep the network tab open so we can see the call to the API here and see if that actually works. So what this should be doing is it should be starting up the function, and then it goes to that Cosmos DB that we made where it uploaded JSON and shows the data. And yeah, so it went to our Salmon Forest at /API/resources, and then it showed the data here. So yeah, loaded it again. So this is basically in a nutshell how you can get, definitely this is quite simple, but kind of a simple web application into Azure using the Azure Static Web App serverless, basically, and GitHub Actions in this case. Now, you can also use something called Azure Devops, which is another CI tool. It also supports that as well, because you can give, so Azure DevOps is another CI tool from Microsoft for you to be able to do basically the code deployment, like what this GitHub Actions did. And that is another supported one with Azure Static Web Apps that works as well. Okay, let's see. Any questions from anybody so far? One thing I realized I didn't go through, and I can go through a little bit more, is the two JSON files here for the Cosmos DB, it's not Cosmos DB, for basically creating the resources in Azure. The way it works is it has a certain structure, and this is something actually I could get from the Microsoft documentation, and I didn't have to actually tweak it too much, which was nice. But these parameters are the way that you can basically give values to things that you want to dictate, right? So in the case of the Cosmos DB, I want to give a specific name. The location here is defaulted to the resource group location. And then I want to give a database and a container name as well. And the way these are used later is these, what are called resources, are what are created inside of Azure. So the database account is the actual Cosmos DB database account, meaning the Cosmos DB Cloud Workshop that I see here. It is an Azure Cosmos DB account. So that is what is this type of Microsoft Document DB database accounts. And I did enable free tier for it. And basically it uses the same location. And these are properties that basically enable the free tier for the Cosmos DB account. And then the other resource here is the SQL database, because I wanted to create that Cloud Workshop database in there automatically. So that's what this is doing, where the name of it does need to be formatted as the account name / and then the name of the database that I'm giving, which is Cloud Workshop. So that's what this is doing here. And then it took the ID of this database is the name that I gave as a parameter. So that's how it's plucking out from parameters, using that as the resource ID. And you also give this depends on, because since you're giving an array of resources, you can say what depends on what so that it creates it in the correct order, because you can't create the database before the actual account itself is not made. So by saying depends on, it's a way for these resources to, it's a way for Azure to then know, okay, first I had to create this, then this, then this, because of the dependency. So that's what this depends on is meant for. And then the container is within Cloud Workshop is the resources container that contains all my actual data. So this is for creating that container with that partition key. And it also has a depends on, because it does depend on the database. So by using this is how it knows to create the 3 resources in the right order. And then for the static web app, it's just the one thing, because there's just one static web app to make. And it took parameters of name, the location again, and the app settings, because of those configuration settings that I wanted to give. And that is specific, obviously, to my use case. But generally with APIs, you're going to more than likely be talking to some sort of a database or some sort of a persistence. So more than likely, you're going to have to be giving some external configuration, which is called as app settings here, basically. So this is pretty much how you create the static website. Fairly simple, I think. This lets you put in the app settings in there. Anything else to go into? Yeah, I think that's pretty much all I have that I could think of to discuss here. Not seeing any questions in the chat. Go back here, make sure I didn't miss anything. Yeah. Cool. So what I'm going to do now is I'm going to stop the recording. I can. Yeah. I'll go and stop the recording. If you want to ask questions or have anything, definitely feel free to put in the chat, or I think you can also unmute yourself if you're comfortable, of course. But yeah, I thank everybody for coming and joining, and I hope that this made sense. We covered a lot of different things, obviously, but I hope that it made sense.